Or if the tangent is given, we may integrate to find the equation of the curve and so on, whatever the statement is. Next subtopic. Before we move on to this, I'll just recall how we used to differentiate the logarithmic function. So let's say the function was y is equals to ln x. So dy by dx was 1 over x, whatever is inside the bracket, and then multiplying with the differentiation of whatever is inside. So y is equals to ln 3x plus 2. So dy by dx is going to be 1 over 3x plus 2, whatever is there, and then multiplied with the differentiation of whatever is inside the bracket. One more. Y is equals to ln 3x square plus 2. So dy by dx would be 1 over 3x square plus 2 into differentiation of this is 6x. So a short form for this could be that whatever we are doing, after that we are getting the function in the denominator and its differentiation in numerator. If you would observe, see, this is x and this is its differentiation. This is 3x plus 2 and this is its differentiation. That's 3x square plus 2 and this is its differentiation.
So we just put it in the denominator and then we multiply it with its differentiated.
Yes.
Okay.
So if we have dy by dx in this form, that we have the function in the denominator and we have its differentiation, f dash x is its differentiation, we could write the equation as y is equals to ln. If the differentiation is present there, we can write ln f of x plus c. For example, if I write y is equals to 3x over, or let's say that's just x square plus 2. This is dy by dx. So I just need to check that if the differentiation of denominator is there, and I'm thinking the differentiation of this denominator is actually 2x. So I need to have 2x in the numerator. So what we would do is dy over dx is equals to, I'll write that 2, I'll write this 1 by 2 and x square plus 2. Now see, differentiation of this denominator is exactly present over it. So we can write 1 over 2 ln x square plus 2 plus c is the equation. If you
But
would
I'm still kind of
differentiate this,
confused.
you'll exactly get that back. Sorry, what did you say?
I'm still kind of confused.
I'll make it clear. We'll go step by step. See, integration of function of this type. When we are integrating 1 over x, that would simply become ln x, right?
Okay, yeah.
When we have 1 over ax plus b, we should have the differentiation in the numerator. Or
Okay.
we can rearrange and bring that number out. See if there is 1 over x is clear, I guess. Is it so?
Yeah, 1/x is clear.
Look at 1 over ax plus b. So this is dy by dx. So dy by dx, the differentiation of this base should be a. So I'm writing a in the numerator and then I'm writing 1 over a. Does that change it mathematically?
No, we just took a out.
Yeah. Now see, the differentiation of this function is exactly present over there. So I can write 1 over a ln ax plus b. 1 over a just stays there as constant.
A over ax plus b is ln ax plus b?
Yes.
But we already took the 1 over a out of it. And how did we also have the ln from it?
See, you will get it if you differentiate it again. See, if this is the question, that's y, and I differentiate it to get this back. Now try dy by dx. How was it? This was writing this 1 over ax plus b and then multiplying with the differentiation of what's present inside. C is just constant, that would disappear. And this a cancels out with this a. What are we left with? Ax plus b. See? Differentiate, you get that back. Integrate, you get the other thing.
Okay, so we just turned the ln ax plus b to 1 over ax plus b?
Yes.
But then it was a over ax plus b.
Yeah, that's in front of you. That's right.
So 1 over x plus b and a over x plus b is the same?
Yes, because a could be cancelled out with a. See this a and this a.
Oh, so it's multiplied over there, which would go into the numerator, and then it would cancel with the a and the denominator. And it would just be 1 over ax plus b. Okay. The
Yeah.
same as the differentiated. Okay.
Try these worked examples. All three of them.
So for first one, we just take the 5 out. So it's just 1 over x. And that'd be ln x. Okay. And then, yeah, plus c. Second one, okay. Wait, I don't understand the second one. So we took out the 1/2. We took out the 6, and then we took out the 1/2, but then we still had the 2x plus 5.
Okay, right. Write it this way. Just take out 6 outside. And
Okay.
then you have 1 over 2x plus 5. But you should have the exact differentiation present over it. So what if I write 6 by 2 multiplied with 2 over 2x plus 5?
Wait, could you repeat that?
6 by 2 multiplied with 2 over 2x plus 5.
6 by 2 times 2 over 2x plus 5. But we're having the 6
See that
because
same mathematically.
6 by 2 times 2 over 2x plus 5.
If I write it like this, see there's no change mathematically. 2 would cancel out with 2, 6 will come back to its place.
Oh, okay. But then in the way that, so then we
See
would
this,
cancel one?
this is actually the original question. What if I just write this is not related to integration, just showing that it is equal? What if I just write 100 and 100? Is it same mathematically? See this
Yeah,
question?
it is.
So we don't change it mathematically, but we're changing the fraction to meet our needs. So I'm taking the x's out. When I do that, I'm left with 1 over 2 x plus 5. But I should have the differentiation of this present there in order that I can use ln easily. So I write 2 and I divide by 2. I multiply by 2 and divide by 2. So I get this fraction.
Oh, okay.
When we
Yeah,
have
we
that,
get the
now
1/2.
as 3 ln 2x plus 5 plus c.
Okay.
You can try this same and differentiate it and see if you get this.
What would the two multiply? Like the two, we'd have to have like another two, right, for the three to be the six again.
You're trying differentiation again?
Yeah, I'm trying to turn it back to the B part.
Right, right, will change. Just try it the simple way. 3 stays out, 3 into 1 over 2x plus 5, and
Yeah.
then multiply with the differentiation of what is inside the bracket. You will get to
Oh,
6.
okay. Yeah, two. So then yes, it would be six. So that'd be 6/2x plus 5.
Yes. Now try C part and be careful with the negative sign.
-2 ln 3 minus 4x plus c.
That's right.
Okay.
Now see one more thing. Why are we using this ln technique? It is because if we ever had this question, 1 over x square, we can just rearrange it as that x minus 2 and integrate it easily. That is power plus 1 over new power plus c, and this would become minus 1 over x plus c. But what if we had as 1 over x only? Then we can't do that, because when we add 1, that becomes 0 over 0. Now it is undefined.
So we would do ln.
Yes, that is why we used ln for all of this. And just go through this once, like generic formulas, basic terms, general terms, and then we'll jump to the exercise.
Why her methods do not work?
Sorry?
Why her methods? It's asking why her methods do not work.
Okay, okay, okay. Let me have a quick look. Yeah, in the third line, because when you will add 1, the power will become 0, so the denominator has to be 0.
When you add one, the power becomes 0. Oh, wait.
Yeah, there's
Because
negative
it's
one already.
-1? Oh, then it would be 0, so it's undefined, like we said. So then it's going to be
When we
unsolvable,
put
right?
0 in the denominator, that would be undefined. That's why it's failing. So we use ln technique.
Okay.
Okay. Few practice questions. I think we are already familiar with the first five parts, first six parts.
What about I part? 2I.
Yeah, let's do that. Now see if I'm just looking at the bracket, differentiation of the bracket must be 5 and that is already there. Actually don't have to change it, right? The question says that integrate 5 over 2 5x minus 1 dx.
Oh no, I meant 2I part.
Yeah, if I just take out 1 by 2,
Yeah.
this is already the perfect state. See, differentiation of base is already present in numerator. So this is 1 over 2 ln 5 minus x plus c.
Okay. Oh wait, but I thought that we ought to also. Oh wait, we already multiply it with the differentiated form anyway, so it would be in the numerator. So that's why.
Yes. Okay. Try question 2a. Remember, ln is there only when we have power 1 in denominator.
Okay. This one has it, right? Just the x itself. But we would have this like
Yeah,
some
that's a
more.
mix. Question 2a. Integrating 7x plus 1 plus 2 over x dx. So integration of 7x would be 7x square by 2 plus x plus 2 ln x plus c. Any issues?
No, we just did plus 1 the power, and but the one, the one will turn into x.
Yeah, yeah. Because it was 1x raised by 0.
No, the plus 1 itself.
See if you have this. dy by dx is equal to 2. It would change into 2x plus c. There was this x with power 0. It comes back.
Oh yeah, okay, yeah.
Try question 2c part. And you have to open the square before you integrate. Is it done?
Almost. I'm on the last step. Wait, so at the end, I was getting 9 over x, so we don't change it, right? We don't change it to ln.
No, that was already 9 over x square. So that is basic term which we could integrate.
Okay. So then it's just
Over x,
change
Z.
5 25x plus 9 over 2 9 over x minus 30 ln x.
Yeah, and that would ultimately change into negative sign because power
Oh,
plus divided by new power.
yeah. Okay.
So this thing needs a little practice. Everything else is same. Like
Wait, this is chapter 13, right?
15.
15. Okay. 15.
Then we'll be on kinematics, and then we're left with two topics: vector and combination permutation.
Okay.
Okay, try F part, then we'll try a few statements and then move on.
For f part, is it 3x cubed minus 12 over x squared minus 24 ln x plus c?
Let me check. So it's 15.6 to F. This one.
Oh, I
Is it?
should have kept it. I should have kept the 4 over 3. The negative carries. Okay. That's.
Is it clear? You want me to solve it?
No, I understand. I know how to do it. Yeah. 3x cubed, that's correct. Minus 4 over 3x cubed, that's correct. That was the step before because I moved the 3 to the side and we can't do that. And it has to stay below. And then minus 12 ln x. That's correct. Oh, wait, minus 12?
Yeah.
I got. I kept the
That
24.
would actually be minus because this is a square minus 2ab plus b square.
No, I got a value 2 times larger. Instead of 12, I got 24.
See, 2 3 times is 6, 6 2 times is 12. When you apply 2ab, this would be the term minus 2a, in fact, a. And then b is 2 over x square. So x would cancel out with this square, and we are left with 1x in denominator. And 2 3 times is 6, 6 2 times is 12, and this negative carries on.
Okay.
That's how you're getting this minus 12 ln x. When you integrate, that will be negative and negative 12 ln x. We
Okay.
just take that negative outside, and like you can write it as minus 12 into 1 over x. And this part could be integrated.
Yeah, ln x. It was just a miscalculation. All my working was the same.
Yep. Let's see the next
I'll do
sub.
more practice on this myself.
Further indefinite integrations. This is just an additional exercise, more numbers to integrate.
I could also do this as practice.
Yeah.
It's the same things.
Yes. I'm just going through this if we have anything a bit different. Okay. If differentiation of this is small f of x, then integration of f of x would be the function back plus c. So we're differentiating this. We're just going through it step by step.
Big F is the integrated version and the small f is the differentiated version, right?
Yes.
Okay.
So if we have this question x squared plus 1 over this and we differentiate it, this is actually u over v, and differentiating it, we get this. And then it says, hence find this. Now, see this, if this is the original question, we are trying to make it look like that. This is already 2 into 3x square minus something, and this is 3x square minus something. So we just adjust that 2, which becomes 1 by 2, and we bring the original differentiated to integrated version back and just replace it. Are you getting the catch?
Sort of.
Okay, see, this was the answer, that there's 2. But the new question, the 2 is missing. So we just adjust it. Let's say this whole is the new part. The 2 is missing. So we put that 2 there and we put that 1 by 2 there. So mathematically, no change.
Yeah.
Now we actually know that with the 2, the integration would be this, because we got that after differentiating. So we just replace it. We keep our 1 by 2 outside and replace the inside part.
So we take the 1 by 2 outside to adjust the one without the 2.
Yes.
And then afterwards, we have the 2 inside. So it's just, we already knew that it was going to be with the 2, but there was one. Why did we have one that didn't have the 2?
Let me show you. Let me show you. We already know that in integration of this part would give me this, right?
Yep.
But what if I remove this 2? What if I ask you to integrate this? Now I don't have anything. This is changed. So basically, what was happening, if there was this 2, then I can write this part. So for this new thing, we write this 2 ourselves and we divide it by 2, making it no change. See, compare these two.
But why did we take out the 2 in the beginning?
We never took that out. That is the second part. In the original part, when you differentiate this, you get this. And reverse of that should be possible.
Oh,
But the
so we had
without the 2. So we make our adjustments of the constant multiplied and divided.
so basically we first differentiated the one that was at the top, and then afterwards we had the other one at the bottom, and then we had to adjust it so it looked like the one at the top, right?
Yes. So
So
now
we
when this
we
question is there, I don't know what its integration is, but I do know what this would integrate to with the 2. So we bring that 2 back and we divide with this 2 in order to make it look like the original one.
the original one at the top, right?
Yes. So this was the question. The 2 is missing. We bring the 2 in, multiplied to make it look like this. And we also divide by 2. So there's no mathematical change in the original question.
So then how? Oh, so the inside looks like it, but the outside is still mathematically
Yes.
accurate.
So we just keep it there, and I can now replace all of this with
With
this.
that, okay. And then afterwards, how do we get rid of the 1/2? Do we?
We don't do that. That
We
stays
keep
there.
it?
Yeah.
Oh yeah, it's there. And the x squared plus 1 is over
We
the
use
2.
this to.
Okay. So we would have, so if a question was asked like this, we would have the top, and then we would differentiate it ourselves, and we would have the one that's uncompleted, right?
Yes.
Okay.
Similarly, differentiating x sine x with the respect to x. And then there's this second part. So the first part first, x sine x. So we are differentiating it. This is first function into differentiation of second plus second function into differentiation of first. Now that's done. Now the examiner says in the second part that integrate x cos x. So we are integrating x cos x. May we just let this up
Yep.
and now see when we differentiate this, I get x cos x. So if I will integrate x cos x, I should get that back x sin x. That's what
Yes.
we're doing. So x cos x gets back to x
Wait,
sin x.
when we differentiate the x sine x, we got the integrated form of the x cos x?
Let me write it separately. We had this x sin x.
Yeah.
I'm going to differentiate it. This becomes, let's say that was y, and dy by dx will be first function into differentiation of second plus second function into differentiation of first. So this is x cos x plus sine x. Done? Now
Yeah.
new question. It says integrate x cos x.
Oh, so they're connected. That's why it's asking us to find it with respect to the x.
Yes.
So then we would split it like we did, and then it would be equal to the x sine x. Then it would be minus the sine x dx.
Yeah. See, when we differentiate this, we get this. But the examiner is asking to integrate x cos x only. So this was something we got after differentiation. Let me write that A, B. We differentiated a to get b. So don't you think if I would integrate b, I should get a back?
Yes.
So b is already there, x cos x plus sin x. If I would integrate it, I should get a back. That means it should be equal to x sin x. Is that correct?
Because we're just reversing it, right?
Yeah. Now see, this is the question. This is the question. I'm rearranging to make this the subject. May I just split these up, integrating x cos x plus integrating sin x is equal to x sin x. See, this question is being separated now. I'm keeping it on left hand side. So technically, if we take that on the right hand side, that's x sin x minus integral sin x dx. So that's x sin x already. And integration of sine would be minus minus cos, minus minus plus cos x plus c. Done. Because whatever we differentiate, that again integrates back to it.
I understand that part, but I'm like confused about. So it's equal to sine x sine x because that's the value we got from the integration. The difference. No, yeah, the integration, right? From the x cos x dx. So then we're just solving it while equating it to that. So then that's why the sine x moves to the other side as a negative, right?
We start from A and we differentiate it to get B. But then the trick part was examiner is not asking to integrate the complete B. He's asking just part of it, that is x cos x. Now what should I do? I do not know. We haven't studied that how to handle u dot v, integration of u dot v. So what we noticed was that if it would have been complete b integrated, we would have just written a. So we wrote that down in generic form here, that integrating b would give me a, one thing. I just copied that down, x cos x plus sin x, copied down. It should integrate to x sin x, copied down. Now waited and focused that I actually need only this. So we can rearrange. I use this integral sign with split part. This could be written as this and took sin x on the other side. Now this is the original question which the examiner asked question. And when sin x is on the other side, that is very easy to integrate sin x. And we got our final answer.
Okay. I think I understand.
One more. We differentiate x cube into square root 2x minus 1. That's again first function into differentiation of second plus second function into differentiation of first. Simple product rule. And we keep on simplify, we get this term. Now see this second part. Examiner is asking you to integrate this. Now I'm trying to see what is the relation between these two, this question and my answer. See, 7x cube is same, minus 3x square is same, denominator is same, plus 5 is missing. Right?
Yeah.
I'll write this question. It says 7x cube minus 3x square plus 5 over square root 2x minus 1 integrate dx. Now, if it would have been this exactly, I could directly write x cube into square root 2x minus 1. Because this is differentiated to this would reverse integrate to that. But we had something else, so I'm rearranging it. And 7x cube minus 3x square, I'm splitting that up. Square root 2x minus 1 plus 5 over square root 2x minus 1. Can we write it like this? Split fractions. Like
Um,
if the question was x squared plus 7x plus 9 integration dx, we could have written it like this: x squared plus integrate 7x
yeah.
plus integrate 9 and dx with all of them. So that's just a split. Why did we split? Because I can see this exactly present over there. And I don't have to go through that process. And I know that when we differentiated this very first thing, we got this, and integrating will make it reverse. So integrating that is reversing it to x cube square root 2x minus 1. And the second part could just be rearranged and integrated. So that's x cube square root 2x minus 1 plus 5. And what's new is power plus 1 divided by new power and divided by the differentiation of what's inside plus c. This simplifies to x cube square root 2x minus 1 plus, that's 5 square root 2x minus 1 plus c. This will need a little practice with patience.
Yeah.
And
I'll do more, I guess. Like, which questions would you recommend from this page? Should I just do all of them?
yeah, in order.
Okay.
That would be better. It like keeps on increasing the difficulty level slowly. So 15.7, and before that we did 15.6, which was handling by Allen method and trigonometric. Trigonometric is easy, just go through one or two questions. Then this fraction ln thing, 2 to 3, and then spend the remaining time on this new exercise 15.7. This
Okay.
would need some effort. Okay, anything else you would like to ask?
No, no questions.